Let's see another one that's similar but different. Okay. If I look at this, I'm gonna change this up a little so you can see better, but you're gonna have to be able to see it from here. But here I have 1 over x minus 2 quantity squared. And I'm going to change this to 2 times 1 over x minus 2 minus 15 equals 0. So now I look to see what, if normally I should have ax squared plus bx plus c equals 0 to solve a quadratic, I really want to find what my x is. And I can kind of see here that 1 over x minus 2 is squared over here, over on the first term. So if I make u equal 1 over x minus 2, that would make u squared equal 1 over x minus 2 quantity squared. So hopefully that makes sense. And then I'm going to substitute, and what I'm going to get is u squared plus 2u minus 15 equals 0. Okay, now this is a lot easier to solve. So again, I'm still going to do my steps, although many of you can do this probably a lot easier than the one with the like the a not equaling 1, but I'll still do the same steps. First step is going to be the greatest common factor. And here, nothing is in common. None of these terms have anything in common. I can divide by 1. Second step, I really want to find two numbers that multiply together to give me a times c. And a, so let's see, let's write down here what a, b, and c are. So a equals 1, b equals 2, and c equals negative 15. So because a equals 1, we can actually do the easier way. So we get a times c is negative 15. And if I add those two numbers together, I get b, and b is equal to 2. If you don't know what those numbers are, that's okay, make a table. If you know what they are, you don't have to make the table. So 1 and 15, not 2. 3 and 5, not 4. And 5 we already have, so those are all my factors. Because I'm multiplying them together to get a negative number, one of these, m or n, have to be negative. And since b is positive, the bigger number has to be positive. So this would give me 14, and this would give me 2. These are my two numbers. Now, because a is equal to 1, I don't have to do the grouping thing. I can literally just say the third step is x plus m times x plus n. But we're using u's here, so we don't really want to use the x's. I'm going to change this to u, and I'm going to say, when I factor, I get u minus 3 times u plus 5. And that equals 0. Okay. So we're not done yet because we now have solved for u, but what I really want to do is solve for x. So we have, let's do this. We have, I can remember that, u minus 3 times u plus 5. So we have u minus 3 times u plus 5. But remember, I said u is equal to 1 over x minus 2. Okay. So now this equals 0. So I have u minus 3 equals 0, or u plus 5 equals 0. And that gives me u equals 3, or u equals negative 5. Which is great, except I want to know what x equals, right? So let's do it. I have u equals 3, but u is equal to 1 over x minus 2, and that's equal to 3, or 1 over x minus 2 equals -5. Now again, how do I solve this? Well, the first thing I want to do is I want to say, for sure, no matter what happens, x cannot be equal to 2. I have to remember that. However you're going to remember that, maybe you write it on your paper with a different color. Maybe you put a star by it, because in the end, if x equals 2, that means that's not a solution. The reason is because that would give me a 0 in the denominator. 1 over 2 minus 2 is 1 over 0, which is undefined. So once I do that, now I can start solving. And what I'm going to do is I'm going to multiply both sides by x minus 2. When I do that, this x minus 2 cancels with this x minus 2, and I get 1 equals 3 times x minus 2. 1 equals 3x minus 6. I add 6 to both sides. I get 7 equals 3x. Divide both sides by 3. And I get x equals 7/3. So that is one solution to this problem. And I do the same exact thing, and 7/3 is not equal to 2, so we're okay. I do the same thing for the second part. So I'm going to multiply both sides by x minus 2. This will cancel with this, and I'll end up with 1 equals minus, and I'm going to distribute. So I get minus 5x plus 10. I subtract 10 from both sides, and I get -9 equals -5x. Divide both sides by -5. The -5's cancel, and I get x equals -9 over -5. But a negative over a negative is the same as multiplication. They become positive, which gives me 9/5. So x equals 9/5 is my other solution to this problem. So I have two solutions, x equals 7/3 and x equals 9/5. Again, we have another, let's see how many more problems. Okay, again, we have another question here. And this one, again, we're going to do a similar thing. So I look to see what my x is, and I'm going to say, let's let u equal x to the 1/3 power. Because if I square that, I get x to the 1/3 squared, and we use our rule that when we have a power to a power, we multiply, and we get x to the 2/3. So that's perfect. So now we get x squared minus 9x plus 8 equals 0. And I'm not going to go through all the steps. I think you guys should know the steps by now, but I do know that I'm going to have 8. So 8, I need to get 8 and 1. And because I have that negative, it's going to be -8 and -1. Those are my two values that are my m and n from the past. So, and a equals 1, so I can just say this is x minus 8 times x minus 1 equals 0. Okay, and if you FOIL that back together, you'll get back to the x. Actually, these should all be u's, because otherwise we're going to get very confused. So we have u squared minus 9u, and we get u minus 8 times u minus 1. So now we know that u minus 8 equals 0, or u minus 1 equals 0. So u equals 8, or u equals 1. And now I'm going to put my x in. So I have x to the 1/3 power equals 8, or x to the 1/3 power equals 1. Now, I'm not sure if you guys know this, but x to the 1/3 power is the same as the cube root of x. Okay, so basically, if we have a base to some fractional power, I'll call this, I need to do it better. I'll call this m over n. That's equal to the nth root. So the denominator goes on the outside and the m goes on the inside. We could also say it's equal to the nth root of b to the m power. Sometimes this is a lot, the second way I did it is a lot easier way to solve. Basically, I'm going to have to, so since that's x to the 1/3 power, I literally have to, how do I get rid of the 1/3 power? Well, the same way I get rid of the 1/2 power. So if I take the square root, I square it. If I have the cube root, I cube it. I would basically, what I'm saying is I would put them both to the 3rd power. Okay, because x to the 1/3 to the 3rd power, if we multiply the powers, we get 3 over 3, which is 1. So x to the 1 equals 8 to the 3rd power, and 8 to the 3rd power is 512. So I have one of my solutions, or again, I do the same thing here. I do them both to the 3rd power, and here I get x equals 1, because 1 to the 3rd power is 1. So those, again, are my two solutions for this problem. Okay, so now we have a radical inside. We don't really need this. We have a radical inside, and now this is no longer a polynomial. Okay, so the easiest way to start this is to try to get the radicals on one side. So basically what I mean by that is I'm going to add 2 to both sides, which gives me the square root of x minus 1 equals x minus 7. And now to get rid of this radical, I have to square it, right? Because when I have a radical, I square it to get rid of the radical. They cancel. Or if I have something squared, I take the square root of it, and the squared and the square root cancel as well. So if I square that side, I also have to square this side. So what do I get? I get x minus 1 equals, and then x minus 7 squared is the same as x minus 7 times x minus 7. So be very careful, because it's not x plus 49. And sometimes people do that. It's you square what's in the parentheses, okay? And I can give you a formula for that if you want to remember this. This helps me. I can do things really fast because I know this formula. Actually, if this is a minus, then this is a minus, and it's always a plus b squared. So now I can actually multiply those using this formula pretty quickly, because it's x squared minus, and then it's 2 times, for this problem, a equals x and b equals 7. So I have 2 times x times 7, which is 14x, and then b squared, so -7 times -7 is positive 49. Okay, and then again, I have to make this equal to 0, so I'm going to subtract x and add 1 to both sides, minus x plus 1. And here I get 0 equals x squared minus 15x plus 50. And now 50, well, a factor that should work is 5 and 10 because 5 and 10 equals 15. So I have my two values are 5 and 10. I'll call this M and N since I've been using those letters. And since it's positive in the last, that would work. But if I add those, I'm going to get a positive number. I need a negative. So I'm going to make these both negative. So I get 0 equals, and when I factor it, I get x minus 5 times x minus 10. And then I solve. So either x equals 5, I think you know how to do this, or x equals 10. So now here are my two solutions. But whenever I have a radical, it's very important that I check my solutions. So I have my original, which I'm going to copy, and I'm going to paste. And then I have my two solutions, which are 5 and 10. So x equals 5, x equals 10. And what I'm going to do is I'm going to plug them in and make sure they work. So I have the square root of 5 minus 1 minus 2 equals 5 minus 9. So here I get 4 minus 2 equals 5 minus 9. Sorry, the square root of 4 minus 2 equals negative 4. 2 minus 2 equals negative 4. Well, that's not true. That means x does not equal 5. X equals 5 will not work. So I'm going to come over here and do the same thing with 10. I get the square root of 10 minus 1 minus 2. Does that equal 10 minus 9? So here I get the square root of 9 minus 2 equals 10 minus 9. Square root of 9 is 3. 3 minus 2 equals 10 minus 9. 1 equals 1. Check. So my only solution to this problem is x equals 10. The other is called an extraneous solution. It does not work. Okay? The reason it doesn't work, and we'll talk about it here. So the reason it doesn't work is because when we square something, the answer would have been negative 2 equals 2, which is not true. But when I square them, I get 4 equals 4. Since how I started this problem was squaring both sides, I could have this one solution that doesn't work. So what does it say? It is often essential to always check your answers after solving an equation in which the operation was performed. So this is with whenever you have a radical, always you have to plug it back in. This squaring operation is usually used when solving an equation involving square roots. So whenever you square something, remember you square it because you had a square root. This is going to get rid of the square root, but we could have this solution, one solution that doesn't work. So please make sure to go back and check it. If you check it and they both work, then those are both your answers. If you check it and one doesn't work, then that one you just cancel out. And for example, like this one, and we only had one solution, which is x equals 10. X equals 5, we can see does not work. 0 does not equal negative 4. And that concludes section 1.4. I'm sorry, 1.6. Yes, 1.6. So thank you very much.